This lecture talks about the basic renal physiology, and we'll talk about the primary functions of the kidney. For example, the regulation of fluids and electrolytes, as we can see here. The regulation of the acid-base balance, which involves the hydrogen ion as well as the bicarb. The elimination of toxins that pass through the ultrafiltrate. And we'll talk about the hormonal involvements that the kidney is involved with using the renin-angiotensin and the erythropoietin. So we'll talk about the renal blood flow, and we can say that the kidneys receive approximately 20 to 25% of the cardiac output. So if we say cardiac output's approximately 5 liters per minute, both kidneys combined receive approximately 1100 mLs of blood per minute, which is 20 to 25% of the cardiac output. And out of that renal blood flow, the urine output is approximately 1 to 2 liters per day. And that's in hopes to get rid of all the metabolites and the toxins within the body. It's excreted via the urine. And we'll talk about the factors that are involved with regulating the renal blood flow, such as the autoregulation, the feedback systems, for example, the macula densa, certain hormonal influences on the kidney, for example, the renin-angiotensin-aldosterone system, and certain neuronal factors, for example, the sympathetic tone, all help to regulate the renal blood flow. Then we'll talk about the arterial system within the kidneys and the different branchings of the arterioles that supply the kidneys the blood supply. Then we'll talk about the functional unit, which is the nephron, and there's approximately 1 million functional nephrons within the kidney. And we can say from a conceptual standpoint that the glomerulus works to create an ultrafiltrate from the plasma, which is filtered through this Bowman's capsule to create an ultrafiltrate. And that ultrafiltrate consists of many different electrolytes from the plasma. For example, sodium, chloride, phosphate, certain amino acids and glucose, calcium, magnesium. All these electrolytes have to be reabsorbed or perhaps even secreted through the different parts of the nephron. So we can say that the glomerulus works as a filtration system that filters the plasma through a capillary system within the Bowman's capsule that creates an ultrafiltrate that contains many different electrolytes, anions, cations, amino acids, and glucose. And the proximal convoluted tubule works to reabsorb and secrete various electrolytes and anions either into the proximal convoluted tubule lumen or to reabsorb back into the capillary system, which will eventually become systemic. And then we'll look at the loop of Henle, and we can say that the loop of Henle works. Two major functions are to reabsorb certain electrolytes and to create a certain phenomenon, which is the countercurrent multiplier. And we'll see later how the countercurrent multiplier sets up the environment of creating a hypertonic environment within the medullary portion of the kidney, so that later on the ultrafiltrate, which enters into the collecting tubules under the influence of the antidiuretic hormone, stimulates the aquaporins, or the water channels in which water is reabsorbed through the influencing factors of the hypertonic environment of the medulla. So the loop of Henle, once again, works to reabsorb certain electrolytes and to create this countercurrent multiplier, which will have an influence on the convoluted tubules, or the collecting tubules rather. And we'll see here, this is the reabsorption which we just talked about in the loop of Henle. And then the ultrafiltrate enters into the distal convoluted tubule, which has the influencing factors of reabsorption of certain electrolytes and the secretion of certain electrolytes. And then we finally enter into the collecting tubules, And we can see there's two primary differing collecting tubules. For example, in the cortical collecting tubules, which we can say the primary function is the reabsorption and secretion of differing electrolytes, as well as the management of the acid-base, or the regulation of the acid-base pH system. For example, the reabsorption of bicarb and the secretion of hydrogen ions help to regulate the acid-base. And then the medullary collecting tubules, which we talked about before, are under the influence of the antidiuretic hormone, ADH, which is produced, or rather released from the pituitary gland, and stimulates certain receptors, which ultimately help to create water channels, or opening of water channels called aquaporins, so therefore you can reabsorb water back into the systemic circulation and increase your blood volume. And ultimately, through this whole process, there's a formation of urine, which is the excretion of metabolites and certain waste products. So in the next lecture, we'll talk in more detail about each system of the nephron. And just as a quick review, we talked about the glomerulus creating the ultrafiltrate from the plasma, from the blood supply that's going to the kidneys. The renal blood flow goes through the glomerulus, or the Bowman's capsule, to create the ultrafiltrate. The proximal convoluted tubules work to create reabsorption or secretion of electrolytes, anions, cations, goes down the loop of Henle, and the main function is reabsorption and creating a countercurrent multiplier environment. And it continues up into the distal convoluted tubule, which again, the process of reabsorption and secretion, to ultimately until where you get to the collecting tubules, whether it being the cortical collecting tubules or the medullary collecting tubules. There's a process of reabsorption and secretion of ions. There's a process of regulation of acid-base, and there's an influencing factor of the antidiuretic hormone, which allows the reabsorption of water. So in the next lectures, we'll talk about each individual part of the kidney. We'll talk about the regulation of electrolytes and fluid balance. We'll talk about the acid-base balance, and we'll talk about certain pathologies that can take place with the kidney. For example, acute renal failure and chronic renal failure, and how it would be managed as patient clinically. For example, a patient that has either acute renal failure or chronic renal failure.